All right, hello everyone. My name is Awa. I'm one of the co-founders of Anoma, and today I have the pleasure to moderate this panel on layer 2s for scaling. So why don't we begin with a quick introduction to each of these panelists here. You want to start, Mustafa?
Hello, I'm Mustafa, CEO of Celestia Labs. Should I? Well,
No, that was perfect. That was what I was expecting.
All right, I'm Norswap, you saw me before. I do research and development at Optimism.
Hi everyone, I'm Tomasz, I'm founder at Nethermind.
And my name is Alex. I'm the CEO of a company, Aurora Labs, who is building Aurora protocol.
Amazing. So why don't you just give us a quick overview of how what it is that you're building and focusing on relates to layer 2s?
So at Celestia Labs, we're building Celestia, which is a pluggable consensus and data layer. And it's a layer 1, and unlike most layer 1s, it basically does only data availability and consensus, which makes it a kind of like optimal or minimal layer for layer 2s to build on, such as rollups, for example, and other types of sidechains.
So Optimism is an optimistic rollup, which is a layer 2. So that's very easy.
So at Nethermind, the experience of ours is building tooling for protocol engineering for layer 2, particularly for the Starknet ecosystem. And well, it's been fascinating from the very beginning, learning the possibilities behind the verifiable computation and the future of scaling and the new possibilities for DeFi. So it's challenging. It's really digging deep into the core development. And
I read about you guys that you have actually done a lot of work on Starknet, and you could actually share some of your insights as a builder related to Starknet, as well as we're doing some L2 research yourselves, right?
Yes. So we constantly cooperate with Starknet and with the community, and it's a constant collaboration, discussions, work.
And Aurora itself is an L2 solution to Ethereum. The way how it works is just the Ethereum virtual machine, that it works as a smart contract on top of more performant L1 solution, which is near blockchain. It is horizontally scalable through sharding, and these properties we inherit in Aurora. Because of the very specific design of the bridge that we have, Rainbow Bridge, we are actually capable of making the whole near blockchain an L2 to Ethereum. And this feature is also inherited by Aurora. That's why Aurora is an L2 to Ethereum too. Yeah, and our base token is Ether. So from that point of view, we're pretty close to Optimism, right? Streaming the benefit of the ecosystem back to our roots, to the Ethereum blockchain.
Okay, that sounds really cool, but let's save up some for later, yeah? Awesome. So I would like to get a little bit started with the background around L2s. L2s, what led us to start building them and allocating so many teams and resources and investigating this space of scaling via L2s? What do you guys think gave us this need?
Okay. So Ethereum doesn't really scale as it is currently. So we cannot handle. There's more demand than there's block space, basically, which leads to high transaction costs. And there's two problems, I would say. One is technical. There's issues in scaling it technically. But the second issue is one of decentralization. I think the ruling body of Ethereum has drawn a line in the sand, which is people should be able to validate the blockchain at home. On a laptop, maybe you need to buy a little bit of disk or something, but it should be easy. And layer 2 are a way to preserve this property of verifiability while still being able to scale beyond that.
Yeah, so of course scalability is the main one, the one that everyone thinks about, and probably the most important one. But the other one that is not as discussed as much is that L2s and other types of scaling solutions allow you to extend the base layer with functionality that might not be trivial on the base layer. Interestingly, before Ethereum was even around, we had protocols like Mastercoin and Omni Protocol on Bitcoin, and these were protocols that were basically architecturally like rollups because they used Bitcoin as a data layer. They posted data to Bitcoin, but the execution happened off-chain. And so, for example, Tether is actually based, or was originally implemented on top of Bitcoin using something called OmniLayer. And so, interestingly, one of the biggest use cases here is simply to implement new functionality.
So very often when we think of scaling, we keep thinking of transactions per second. One other aspect which is super exciting in the context of Starknet, like in the projects that I was working on, is the ability to process enormous amount of calculation within a single transaction and don't pay much gas when it's actually commented on the layer 1. So there were examples where we were thinking of what's the future of decentralized finance and what really the traditional finance is missing from the decentralized finance. And it was the ability to compute a bit more complex aspects of derivative products, things like Monte Carlo simulations and the Black-Scholes aspects and so on. So you've seen the workarounds in DeFi space where the volatility would be provided from the outside, where the volatility snapshots would be calculated over many months, and it was very gameable. And now we're coming with the Stark-based solutions where we can calculate the volatility in the last few 100,000 blocks within a single transaction. And that's what we were using with the solutions like Euler Fossil. And yeah, this is also scalability, and this is something that was absolutely not possible and will open a lot of opportunities.
And
Actually, just before you say anything, I just wanted to highlight that I find it really interesting that today we have a team that is working on layer 2 architectures that are not for Ethereum, like initially standard. And this is why I wanted to kind of hear, like, what is the story, what's the background to Aurora, and like the relationship with Mir and how come you came to.
Yeah, so the background for Aurora is pretty simple. We see like that the Ethereum protocol and the ecosystem of Ethereum protocol is extremely well developed with lots of tools. And there is no need to reinvent the wheel there. We have OpenZeppelin, an SDK for the smart contracts, right? Let's use this. They are already verified. They are in a good shape. We have lots of auditing companies who are capable of auditing smart contracts that are written in Solidity. Let's reuse this knowledge. And last but not least, there are already lots of products that are launched on top of Ethereum. Let's just keep them as they are. They are already validated by time in general. So, however, obviously the ecosystem needs to be scaled up, right? We are all talking about scaling here. And for near blockchain, the solution that actually brings the scalability to the blockchain, or like one of the options how it can be scaled, it was a natural thing to understand how we actually can launch all of these smart contracts, how we can reuse the Ethereum ecosystem for near, and then it will bring benefits for both of the worlds. New applications launching on top of near blockchain, and for Ethereum applications, this is going to be an extension of their user base, right? An extension, while some of the users are not captured inside of the Ethereum blockchain, now these users would be able to operate on the near blockchain. And so that was the basis for Aurora to come to life, just to bring two worlds together and use the better pieces of both of them.
So that's very interesting. Here we're talking about initially starting from the point of L2s are designed to scale, and in some facts there was in fact a need to scale Ethereum, scale throughput, but they're also to add other functionalities and better DevX and better UX, but also to, in this case, portability and composability of applications between two different ecosystems. Cool. So about categories of L2s, I feel like the design space keeps growing, right? And to my knowledge, at the moment, the two biggest categories of layer 2 solutions or architectures are, on one hand, sidechains, and on the other hand, rollups. Before diving into any of these two categories, are there any other categories you can think of like layer 2 solutions that have been investigated by projects and research that do not fall into these two groups?
Yeah, so there's payment channels and state channels, but those aren't really too interesting for for smart contracts because it's quite difficult to do like state channels for general purpose smart contracts that scale to a large group of people. But if you're interested in just payments, then payment channels are very interesting. You know, Bitcoin's main scaling strategy, for example, is the Lightning Network, which is a payment channel system.
Any other groups, perhaps in linear ecosystem?
Yeah,
Research?
just for the sake, so the auditory are getting a little bit more into L2s. I just wanted to mention that there are two very kind of distinct types of L2s. These are optimistic rollups and ZK rollups, so there is a difference. I'm not sure whether you wanted to touch this.
I want to like go on later.
Okay, yeah. So optimism is an absolutely great example of an optimistic rollup, while there are other teams in the space that are building ZK rollups. The difference is the finality, the assumptions on the finality on the main chain at which these rollups are working.
Okay, cool. So it seems that the main categories that we have on layer 2 solutions and constructions are primarily sidechains, rollups, and state channels. Now we're going to go into rollups in a little bit.
Can I make a comment here?
Sorry?
Yeah, I'm not sure sidechain should be classified as layer 2.
Really? Oh, it's a shame that we actually did not manage to get somebody from Polygon to come, but I would have really liked to hear those thoughts. But do you want to elaborate on why sidechains are not layer 2s?
Because they don't fundamentally inherit any kind of property from... So a sidechain, to explain briefly, is just a normal chain that happens to manage something on another chain. In the case of, for instance, Polygon, they manage the stakers on Ethereum, but that by itself does not bring any kind of additional properties to a system like security or increased throughput or anything like that.
I would actually agree with this. So from my point of view, Polygon in the proof of stake chain, I cannot fully say that this is an L2 solution. At the moment when Hermes is fully operational, their ZK rollup, then in case this ZK rollup is running on top of Ethereum, then we can say that this is kind of a truthful L2 solution. But there is a way how you can make a side chain or just a separate L1 an L2 to another chain. And this way is pretty straightforward. You just need to have a light client of the chain, encode it in a smart contract in a source chain, put it there, and just upgrade it with the chain. And this is actually what is done in the Rainbow Bridge. That's why I'm claiming that this is a very complicated thing. I recommend to nobody doing this, but this is one of the ways how you can get to that level.
So does it bring any additional property to your chain? I think it's an amazing design, and it's the best kind of bridge that you can make. So it is
Are you
very
claiming
good.
that's an L2 or are you saying it's a sidechain?
Yeah, I'm just saying that in case you have, just think of this, if you have a validator being a smart contract on the source chain, it would mean that in order to, or you have a node, sorry, not a validator, but a node. In case you need to break the source chain, you would need to break also the separate L1. You would also need to break the source chain. So in terms of the security assumptions, they are the same. And this is the main, kind of leitmotif of L2s, right? conserving the security.
Like if your chain, for instance, imagine you have such a chain, it's not very decentralized. Somebody can take over the chain without breaking the security of Ethereum. So I would say it does not inherit the security of Ethereum, for instance.
Well, in this case, they would need to be able to, to also to break this light client.
So you're saying that if the light client says something, then the whole chain cannot.
Right.
The on-chain
that's-
cannot
that's-
override the light client.
Yeah.
Yeah? Okay, in that case, then I agree with you.
In the meantime, Tomasz is there so quiet and smiling. What are your thoughts, really? Is our sidechains really layer 2s?
Well, I think it depends on how you define them. So I used to consistently separate those two terms into sidechains and layer 2s and see them as different. However, people sometimes suggest that just telling that this is sidechain and not layer 2 takes away a significant part of value from given solution, and that's what I don't agree with that much. So I wouldn't participate in discussion to say like this is less valuable. These are two different categories for me because of construction details, but it doesn't mean that they don't bring like enormous value to extend and to scale on Ethereum or layer 1s, any layer 1s, and bring more users and bring more use cases.
Yeah. Overall, from my point of view, the thing that matters is actually the security assumptions, and it is, and they are very different for very different projects that are here on this panel, and in general projects that are there in the blockchain ecosystem, the wider blockchain ecosystem. So this is the thing that matters. L2 or L1 or sidechains, these are becoming more of a buzzwords or kind of marketing type of things, and it's always better to look in the security assumptions and make your judgments depending on this.
That is a great way to lead to the next question that I had in mind, which is, in general, security models from different L2 constructions and what are the trade-offs over there. I was wondering, considering all the categories, rollups, ZK rollups, as well as optimistic rollups, and there are pessimistic rollups as well, like what are the security models of all these L2 constructions? What are the assurances that they are providing for the user?
Yeah, I mean, to add to that and the last point as well, like instead of using the word L1s and L2, it might be more useful to refer to the types of bridging between these chains, because rollups are effectively just blockchains with a certain type of more secure bridging mechanism between that chain and the settlement layer, which could be Ethereum. So like, in general, rollup constructions, whether it's optimistic or ZK, what they try to achieve is what I would describe as a trust minimized bridge between the rollup and the main chain. And what trust minimized means that you don't have to trust any honest majority or a committee or a multi-sig or anything like that to not steal your funds once you deposit your funds into that rollup chain, thanks to fraud or ZK proofs, which prevent the operators of that rollup from being able to like insert invalid transactions to that rollup that steal people's funds.
Actually, I think it would be really useful for the ones that might not be so familiar with the architectures of rollups if any of you could provide a simple conceptual framework around what a rollup is and what is the, let's say, the flow or the life cycle of a transaction, what is involved in a rollup. I think that would be really useful for many people here in the audience.
Yeah, I can take that one. So in a rollup, you've got some nodes of the rollup. Typically, we call them sequencers. They receive transactions and they execute them, just like it's a blockchain, basically. But then they also, let me tell one version and then I'll tell a variant. But the simple version is they take these transactions and they put them on some kind of data availability solution. So it could be Ethereum, it could be Celestia. And then they also post a result on a settlement layer. which is typically a state root that commits to the state of the blockchain. And then there needs to be some kind of way to validate the adequation between, if we execute these transactions, we get this state root. And that's where we get a difference between optimistic rollups and ZK rollups. Optimistic rollups, you assume the result is correct, but there are independent parties called verifiers that don't know the transaction, re-execute them, and if they come to a different result, they can initiate a challenge called a fault proof. For ZK rollups, there's also different ways to do this, but a simple way is you directly post a zero-knowledge proof that the transaction give the good result, and this proof is fairly cheap to verify on the settlement layer.
So to put simply, a common architecture, basically a rollup is simply a user sends their signed transaction to just, let's say sequencer in this case. In the different rollups, they may call it, different constructions may call it differently. And then the sequencer just gathers this set of transaction signed messages from users, and they compute basically a transaction or like a valid state transition for, in this case, Ethereum, let's say. And then what is submitted to the settlement layer, which is Ethereum, is the updated state root that includes optimistically this list of transactions. And the difference between optimistic one and a ZK one is that the sequencer of a ZK rollup produces also a zero-knowledge proof. And then the verification part does not rely on fraud proofs, but instead they rely on the verifier of the zero-knowledge proof. And so, given this, what is the security model for users of optimistic rollups? Like, what is the assurance that is provided?
The model is the same because when you transact, there is no atomic guarantee that of the result of your transaction. Like the ZK rollups, they also aggregate transactions for a long time, and then they post periodically. So it could be a few minutes, a few hours. And so when you make a transaction, you have the result. You sort of have to trust the sequencer that this result is correct. It will not be validated on the L1 blockchain before a certain amount of time. The difference is time frames. Like ZK rollups are more like hours, and the optimistic rollup, we have a very long challenge period to make sure that the challenge can get through and nobody can censor them. But in reality, there are people running verifiers all the time, and so they should catch instantly that there's a problem because they're in touch, they're like communicating with the sequencer.
So could you elaborate on what is the challenging process for me as a user of an optimistic rollup?
The fault proof. Mm-hmm. Oh, that is a whole talk.
Okay.
But yeah, it's so because I'll make it very, very simple. Because on the layer 1 blockchain, you have access to, let's assume, I'm going to talk about Optimism. So Optimism, you have access to all the transactions on the Ethereum blockchain, and you also have access to a state root. And so you need to run the computation that goes from one to the other to verify it. You can't run the whole computation because that's too expensive. So we have a fancy interactive proof process. That's the hard part I will not explain. Mm-hmm. And so you need to send it's maybe a process of 30 transactions being exchanged with the Ethereum blockchain to prove that there's indeed a problem. And if the sequencer stops answering, you also win by default. So it cannot cheese you in that way.
I'm curious to hear from you, Mustafa. Celestia is actually layer 1 that provides a feature that can be leveraged by layer 2s and layer 1s, data availability. How do you think practically, in the short term, we can use data availability, for example, in the case of, can it provide some properties for optimistic rollups?
Yeah, so in general, there's a huge design space for rollups. And Ethereum rollups is just one part of the design space. There's many different types of rollups. There's things called settlement rollups, sovereign rollups, and also Celestiums. But what we're kind of excited about Celestia is that it's this idea of a sovereign rollup where we kind of take a different view of what a rollup is useful for. Whereas the Ethereum view is a rollup is to scale the Ethereum chain to create a trust minimized bridge between Ethereum and that rollup. But from our view, we're interested in rollups. Basically, one of the biggest advantages of rollups is that it allows anyone to deploy their own blockchain with their own execution environment without having the overhead of having to bootstrap their own like proof of stake or consensus network from scratch. And sovereign rollups are basically like a layer 1 chain in that like it's a sovereign chain, except the main difference is that you don't need to bootstrap your own validator set because you can kind of plug Celestia in as a kind of consensus and data layer. And in this kind of setup, like the sovereign chain is not really a layer 2 to some specific like master chain. It's just an independent chain on its own right that was deployed more easily than simply launching a new validator set as you would do if you were normally launching a new chain.
Cool. Alex, what about the security model of the design of Aurora for the users?
So we have been thinking for a pretty long period of time on how to make a proper design of Aurora. We were doing multiple proof of concepts. We were trying to implement EVM as one of the options of the protocol, on the protocol level of the runtimes that can work in near protocol. So there will be, in case we would follow this road, then developers would be able to choose where to deploy their smart contract, at either in near virtual machine or in Ethereum virtual machine. This option was decided to be discarded. And instead of this, our setup is that, according to our architecture, we run EVM just as a smart contract on top of Near. Now, there are multiple benefits that this design brings. Some of them are not yet utilized, but later this year, you're going to see new products that are going to be using these specific features. But there are at least some of the great features of this design that are already utilized. And first of all, it is that in order for Aurora to be able to work, Aurora doesn't need to have its own validators at all, because near validators are validating Aurora. That's why we do not need to take care of the validators. We do not need to take care of the decentralization of the stake of these validators. We do not need to take care of the consensus layer for it, the storage layer, the network. The only thing that Aurora needs to take care of is the runtime. Now, probably right now, Aurora itself is one of the most complicated smart contracts in the world, which means that it has lots of potential attack vectors, because it is the smart contract, and as you know, even this week, many smart contracts get hacked. So it is a kind of shaky position, though we decided that it will be much better that we are reusing, we are not reinventing the wheels, right? We are reusing the existing implementations of EVM that are written in Rust. We started with Sputnik VM. We're thinking of migrating to another options and reusing already things that are developed in Near protocol, right? Like that I mentioned, right? Consensus and all of this stuff. So the thing that we need to do is just to glue these things together. And then the amount of work for us is not that big. And actually, Aurora was built in an astonishing 4 months from the ground up with this design in mind. And this design allows us to iterate extremely fast and introduce new features and move on really, really quick as a startup.
Sounds really exciting. Going back to the idea around assurance for the users, there is the way current rollups are and some layer 2s are architected is that it commonly, as you mentioned, the sequencer component of most architectures are trusted and they are centralized. So my question is really, given that centralization point, it actually does give the the sequencer the power to kind of freeze funds, send some transactions, even like perform some kind of MEV on it if they want it, right? I want to hear like, are there some thoughts towards research directions, implementation directions where we are removing that centralization point from rollups and layer 2s?
One thing that we're exploring at Celestia is rollups without any sequences, and that kind of makes them not rollups anymore because there's no rolling up involved, but it's still like on-chain data and off-chain execution. But you can eliminate the sequences by having users post transactions directly to the data layer, and then you can kind of like separate out the function of generating the state root. And so like you can have a different party to generate the state root, and you can have a ZK proof to prove that they generated that state root correctly, for example, or fraud proof if they didn't. You can actually have a peer-to-peer like interactive verification game. And that effectively allows you to, and if that allows you to remove the sequencer, and if there's an invalid transaction in the chain, all the state root generator has to do is simply ignore that transaction and pretend it didn't exist. And that's kind of like how the original like master coin model worked on Bitcoin, for example.
So there's like, so the problem with the sequencer being centralized is on one part censorship and on the other part liveness, so the chain stops progressing. There's already an optimism to the escape hatch for that. It's that you can post L2 transactions on L1. There's a catch. The sequencer still needs to post the state root. But what we could do, and would be really easy, is to say, well, if the sequencer has posted no state root in a few days, anybody can post a state root. And then these L2 transactions on L1 get included from that, basically. In terms of decentralizing the sequencer, it's not a super hard problem. You can do some really dumb stuff, like just have a small blockchain, you know, like just classical Ethereum model, just much more centralized, because you only need one of the sequencer to progress the chain for it to work. But we're also thinking about some more fancy models, but yeah, they're still in the design stage.
So I think there are multiple approaches being tested for solving the sequencer problem, because obviously we're talking about liveness, censorship, we're also talking about MEV extraction. So I've seen the kind of two-pass approaches where someone else, so all that family of two-pass approaches like proposer-builder separation, which is now being introduced on Ethereum for the merge, where you have someone else building the block and someone else actually proposing it to the network. So you can have similar solutions with the sequencers where you create a decentralized network of builders who compete for the most valuable block, and then a sequencer is forced to choose the one that offers the highest value. And the value is very often derived from the MEV opportunities. Then we do have the family of exploration research into the cryptographical solutions. So going for the pre-trade transaction encryption, where the sequencer doesn't really understand what they're sequencing, and it usually involves the problems of, well, then you have to have the computation of these transactions execute in the cryptographically secure way, and this is a big next steps to execute. So it's hard to answer how long we'll be waiting for this one. And then there is a family of solutions which actually introduce the similar to existing blockchains group of validators, sequencers that are decentralized. Anybody can join the sequencers list, or more like anybody can stake to be sequencer, and then they're risking of losing of that stake if they misbehave, if there's some kind of voting of confirming their misbehavior. So I think the solutions are coming. Like the teams like Flashbots are looking into the problems of layer 2, sequencing the layer 2 ulcers. The builders of layer 2s are thinking about it as well, of like how to really remove that responsibility from themselves, because, well, any layer 2 will be aiming at decentralization in the long term, and they're just in the process of incubation when they run the only sequencers. But in the long term, you want to allow others to do that, just simply to get rid of that responsibility. Say, yes, this is a decentralized solution. So there is a motivation on all the sides to actually do it right. The MEV market participants, the L2 builders, the users. That's why I think that this will be solved.
So a 30-second comment from my side. From my point of view, for all of these problems, we already do have a solution. Solution is blockchain itself, right? This is something that brings us censorship resistance, and in case the blockchain is truly decentralized, right? So from my point of view, the most prominent way how to solve the sequencer problem is the last option that Tomasz mentioned, making sure that the sequencer is decentralized. And this is one of the, and if you will think about the Aurora solution, our own sequencer is near validators, right? Is a near blockchain, right? So from that point of view, this problem is less relevant for our solution.
Changing slightly topics, between optimistic and ZK rollups, from the developer's perspective, builder's perspective, do you guys think there are any particular trade-offs, or what makes one developer builder lean towards one over the other?
I think that working with all the builders for the last years and also training developers in the space, I noticed that the notion of finality is the one that escapes from the intuition of many developers. So you have the Web3 developers that build the UIs but don't think about the reversal of data display because maybe the chain that they're building on is not really having instant finality. So the time can run backwards, and you have to present it to the users in a non-confusing way. And then you realize that it's not happening because the developers themselves have problem reorganizations with storing the events that are reversible and so on. So, and particularly finality is the biggest differentiator between optimistic and ZK rollups, right? So now if you talk about the fraud proofs that can take up to a week, obviously, yes, I agree that in most of the cases they'll be happening very fast. Then introduces, like, this just even exacerbates the problem. And any layer 2 will have this like two-stage finality question of like, okay, so what's the finality of the actual layer 2? And then there is the second level finality. And now I remember when we were building the block explorer and that question was coming. So when you reverse, when the finality happens in layer 1, but then you have to reverse something that is already finalized. When there's no finality on layer 1 yet, but the things are theoretically finalized in the context of layer 2, but they still can revert because layer 1 reverts. Yeah, I think we want to have like the finality problem as simple as possible. It's a bit more of a problem in optimistic rollups because the ZK ones come with this clean way of verifying, okay, that's right, and it's happened, and I can cryptographically prove it.
Yeah, I completely disagree. Because dApp developers do not run the proof verifier. Actually, proof generation is extremely expensive, so the proof will not be available immediately. It will be available after 10 minutes or maybe a few hours in practice. So you have exactly the same problem. You have a shorter time frame, I agree with you on that, but the problem needs to be managed all the same because there's no instant finality. And not even close to instant, right? It's not like you can wait 60 seconds and be fine.
Also, if you want instant finality for your optimistic rollup, you can just run a full node for that rollup to see that a fraud proof cannot be generated.
Yeah, I think very serious dApps should run rollup nodes actually. At least right now it's still feasible, but that's like wishing. Like I don't think all the bridges run rollup nodes, and they really should. So dApps, it's like a pipe dream.
Just to tap into this conversation here, I do believe that for developers, the thing that really important is not to have a vendor lock-in in general, to be able to migrate in between solutions, because this is something that people expect from Web 2, right? In case AWS is not giving me good service, okay, I'm going to go to Google Cloud. And from that point of view, it is super, super important to us for all of the rollups actually to support de facto standard that we have, which is the fully EVM compatibility, right? So that's why both optimistic rollups and ZK rollups, they need to tend to get to that point when they're there. So this is also adding to the previous people who were speaking about finality and stuff like that. So I believe this is also pretty important to have a fully compatible EVM solution.
Amazing. We're out of time. Could you bring all your hands together? Thank you very much for this amazing panel.